A bus traveled on a level road for 6 hours at an average speed of 20 miles per hour faster than it traveled on a winding road. The time spent on the winding road was 4 hours. Find the average speed on the level road if the entire trip was 590 miles. So first what we want to do is just write down everything that we're given. So I'm going to go ahead and call the distance of the entire trip d, and I'm going to say that that's 590 miles. And I'm also going to let the time spent on the level road be t sub l, and we're going to say that that's 6 hours. And then the time spent on the winding road, I'm going to call tw, and that's going to be 4 hours. And then lastly, we're told that on the level road, the speed of the bus is on average 20 miles per hour faster than it was on the winding road. So we can represent that as S sub L, the speed on the level road, equals 20 plus S sub W. And you don't have to use subscripts when you're doing this kind of problem. I just like to because it helps me keep track of things a little bit better. You could just call this X and this Y, but doing that, I usually just forget what I called X and Y. So by doing it, or by using subscripts, it just kind of helps me remember how I define things. So in the last video, we talked about how to solve this problem symbolically without any numbers, and this time it's going to be a lot easier. So our next step is to rewrite our velocity equation, or our speed equation. So to do that, I'm going to say that SL is equal to the distance traveled on the the level road, which I'm calling d sub L, divided by the time spent on the level road. I'm going to simplify that to dl over 6 hours. But we're also told that that's 20 miles per hour faster than faster than the bus was traveling on the winding road. So we can also say that S sub L equals d sub L over t sub L, which equals 20 miles per hour plus d sub W divided by t sub W. So we're told that the speed is 20 miles per hour faster on the level road than it is on the winding road, which is just what these subscripts mean. So 20 miles per hour faster than the speed on the winding road, which is the distance traveled on the winding road divided by the time spent on the winding road. So let's go ahead and plug in what we know, and we're going to say that dl over 6 hours is equal to 20 miles per hour plus d sub W over 4 hours, which is the time spent on the winding road. Okay, so I'm going to call this equation 1. And I'm going to call equation 2 590 equals the distance traveled on the winding road plus the distance traveled on the level road. So this is equation 2. Okay. So now we have 2 equations and 2 unknowns. And so what we can do is set up a systems of equation. And the way this is set up now, we can use the substitution method relatively easily. So to do that, I'm going to solve our second equation for d sub W. And to do that, I'm going to subtract d sub L from both sides. And what we'll have is 590 minus the distance traveled on the level road is equal to the distance traveled on the winding road. Now what we want to do is rewrite our first equation down here. So equation 1 was dl over 6 equals 20 plus dw over 4. Okay, and then now plugging in d sub W, we get that dl over 6 equals 20 plus 1/4 times 590 minus dl. Alright, and now what I'm going to do is I'm going to go ahead and multiply this 1/4 through using the distributive property. So we have 1/6 d sub L equals 20 miles per hour plus 590 over 4 minus 1/4 dl. So what I'm going to do now is add 1/4 dl to both sides. And then the dl is going to cancel over here. And you're going to be left with 1/6 dl plus 1/4 dl equals 20 plus 590 over 4. Now I'm going to simplify this a little bit, and I'm going to leave it to you at home to check this. But so on the left hand side we'll have that 5/12 dl equals 20 plus 590 over 4. And now I'm going to multiply by 12 on both sides. So 12 here, and then 12 over here. And then on the left hand side, 12s are going to cancel, so we have 5 dl is equal to 240 plus, and then the 4 is going to cancel over here, and then you're going to have 3 times 590. And then we're going to divide by 5 on both sides. And then I'll leave it to you at home to check this, but you should get that dl is equal to 402 miles. Okay, but we're not done yet. So we're asked to find the speed traveled on the level road. And to do that, we're just going to use our equation again. S equals d over t. So the speed on the level road is equal to the distance traveled on the level road divided by the time spent on the level road. So plugging in what we know, we have that SL is equal to 402 miles divided by 6 hours. And what that gets you is your average speed on the level road should be equal to 67 miles per hour. Alright, so let's go ahead and check our work here. So we know that the total distance traveled is 590 miles, and that's equal to the sum of the distance traveled on the winding road plus the distance traveled on the level road, or 590 equals the distance traveled on the winding road plus 402 miles. So then we have, subtracting 402 from both sides, we get that the distance traveled on the winding road is equal to 188 miles. So then the speed of the winding road should be 20 miles per hour less than it was on the level road, but let's check that. So that's going to be 188 miles traveled in 4 hours. And I'll leave it to you to check, but that should give you 47 miles per hour. So that this step wasn't really necessary, but it's just to help us check our work. And so your actual final answer is going to be 67 miles per hour. So I hope this video was helpful. Go ahead and do me a favor and hit like and subscribe, and I hope you have a great day.